So we're going to go ahead and skip over number 5. Number 5 is just like part B and number 4, as well as problem number 3. So go ahead to the right side of your paper, and we are now looking at number 6. So problem number 6 says an initial population of 5 squirrels increases by 9% each year for 10 years. So they want us to write an equation that models the situation. So the initial population is going to be my A. So the initial population is 5. Then to figure out B, I've got to look at what it tells me. Since it's increasing, that tells me I'm going to be adding. And 9% as a decimal is going to be 0.09. So I get 1.09 is B. So since I've got A and B, I can write my equation. Y equals 5 times 1.09 to the power of x. Well, then they ask me how many squirrels will there be in 10 years. I'm just plugging in 10 to x. So y equals 5 times 1.09 to the power of 10. So we plug that into our calculator. 5 times 1.09 to the power of 10. That gives us 11.8. Remember, when we're talking about population, we're not going to have a decimal. You can't have part of a squirrel. So I'm going to go ahead and round that. Since it's 0.8, that tells me it's going to round up to 12 squirrels. All right, number 7. A car purchased for $34,000 is expected to lose value or depreciate at a rate of 6% per year. Want us to write an equation. So A is what I start with. I start with $34,000. That's how much it costs at the beginning. B tells me that it's losing value. So I'm going to have to subtract, and I'm going to have to subtract that 6%. So 1 minus 0.06. When I subtract those, I'm going to get 0.94. And now since I've got A and B, I can write my equation. Y equals 34,000 times 0.94 to the power of x. Now, part B is saying after how many years is it worth less than 21,500? So I'm going to show you both ways, and you decide which one makes sense. So I need to see what x will be when I set 21,500 equal to my function, which is 34,000 times 0.94 to the power of x. So in our Casio, we put the equation in just like how we see it. 21,500 equals 34,000 times 0.94 to the power of x. Once I've got it typed in, I'm going to hit Shift Solve. It asks me if I want to solve for x. I do. So we hit Enter. And give it a minute to think. And we get x equals 7.4. And remember, you just round up to the next number. So it will be after 8 years. If you want to do this in your calculator, we go to, or in your graphing calculator, we're going to go to y equals, clear out whatever's there by hitting clear, and we just type our function in. So 34,000 times 0.94 to the power of x. We want to look at our table, so I'm going to hit second graph, and I'm going to scroll down until this y value is less than 21,500. So after 8 years, I'm at 20,725, which is what we got here. Okay, problem number 8. The population in the town of Alien Acres is presently 42,500. The town has been tripling every 4 hours. So when it tells you something specific like that, go ahead and circle it and make sure you're paying attention to it. So I've got my A. It told me A was 42,500. That's what I started with. Now remember, when it gives us one of those special words, half, doubles, triples, whatever, that automatically tells us our B. So since this says it's tripling, then B is going to be 3. So my function here is y equals 42,500 times 3 to the power of x. Now, it asks what the population will be after 32 hours. Well, pay attention. This only triples every 4 hours. So in order to figure out what x is, I'm going to have to take 32 divided by 4. I need to see how many times 4 hours occurs in that 32-hour span. So 32 divided by 4 is going to give us 8. And then we just plug that into our x. So I've got 42,500 times 3 to the power of 8. And you can use either calculator. It doesn't matter. So when we do that, we get 278 million 842,500 people. Yeah, I think it's people. All right, number 9, circle that one. It's very similar to number 7, so you can reference number 7 for that one. Let's see. Number 10, I think y'all can handle that one. It's similar to number 6. Number 11, let's look at that one together. So it says, suppose a zombie virus has infected 40 people at our school. The number of zombies doubles every 20 minutes. So this is another one of those problems, like up here, where it's giving me a specific time that it doubles. First thing we've got to do is write an equation. So I start with 40 people. Well, then I've got one of those special words that tells me about B. Since it's doubles, then that B is going to equal 2. So since I've got A and B, I can write my equation. Y equals 40 times 2 to the power of x. Now, part B, this is where it gets a little bit more complicated, because now they're asking me how many zombies are there after 3 hours. Well, first thing I need to recognize is that I'm talking about 2 different units. I've got minutes here, I've got hours here. So I first need to change 3 hours to minutes. Well, if you think about it, how many minutes are in an hour? 60. So 3 times 60 is going to give me 180. So 3 hours is the same thing as 180 minutes. However, this doubling only happens every 20 minutes. So I need to take this 180 and divide it by 20. So 180 divided by 20 minutes, that's going to give me my x value. So 180 divided by 20 leaves us with 9. So I get 9 as my x value. At this point, it's nothing more than plugging it into our equation. So y equals 40 times 2 to the power of 9. We plug that in, either calculator, it doesn't matter. So 40 times 2 to the power of 9. And we get 20,480. And that's going to be zombies. Go ahead and circle number 12. 12 is once again similar to number 9, which is similar to number 7. And we're going to look at number 13 together. So number 13, we've got a population P is increasing exponentially. At time t equals 0, the population is 37,000. In 10 years, the population is 44,400. So what they've told me is to start with, I've got 37,000. So to start with, that tells me about my initial value. That gives me my A. So A is 37,000. Now, what's different about this problem is that it's not giving me the rate that it's changing. I've got to find the growth factor and the percent growth. And then I've got to be able to write an equation. So what they have given me is a point. They're telling me after 10 years, it's going to be 44,400. So I've got an x value and I've got a y value. Well, remember, every function for exponential functions is y equals a times b to the power of x. So it's got a that they've given me, x that they've given me, and y that they've given me. So in order for me to find b, I've just got to plug those in and solve. So if I plug those in, my y is 44,400. That's equal to a, which is 37,000, times b, which I don't know right now, to the power of my x, which is 10. So if you're confused, I'll give you a second to jot that down. All I did was plug in a, x, and y to my function. So my y was 44,400, my a was 37,000, and my x was 10. There are two ways that you can do this. We can solve it by hand. So if we solve this by hand, I would go through and I would first off, and I'm going to write in a different pen so we don't get confused. I would first off divide both sides by 37,000. So I'm going to do that in my calculator. 44,400 divided by 37,000 thousand. If I was you, I would just leave it in fraction form. So that gives me 6/5 is equal to b to the power of 10. Whenever you want to get rid of an exponent, you can raise this entire side to 1 over whatever the exponent is. So I would raise this to 1/10. I could raise this side also, because whatever I do to one side, I have to do to the other, to the power of 1/10. And that's very easy to put in the Casio calculator. So if I'm trying to do 6/5, I'm going to press the fraction button. Let's see. So 6/5. And then I'm going to raise that entire thing to an exponent. So I'm going to click that exponent. That exponent is going to be a fraction. So I'm going to make that a fraction, 1/10. Hit enter. And I get, now I'm going to write out a lot of decimals because I want to make sure that I am correct. So I'm going to, I don't know, do 4 decimal places. 1.0184. So 1.0184. Now, let's say you get on the test and there was a question like this and you forgot how in the world we solved this. This calculator can help you solve it. So the reason I started writing in the pink pen is because I want you to go back up to this equation. Remember when we were solving earlier, the calculator will solve this for b as well. So I would say 44,400 equals, so remember, alpha calc 37,000 times b. Now there's not a b for this calculator, so I'm just going to put in x. So alpha parentheses to give me x, and that x is being raised to the 10th power. Remember, once you've got it typed in, we need to tell the calculator to solve. So shift solve. It's asking me if I want to solve for x. Hit enter. And give it a minute to think. The more complex an equation is, the longer this calculator takes to figure it out. You just have to make sure that you're patient. So if you notice, I get the same thing, 1.0184. So that's just a second way that you can do it. If you get on your calculator and are totally stuck on your test and you don't know what to do, then that is one other way that you can go through and solve. Alright, so now that I've got b, I have found my growth factor. My growth factor is simply my answer. It's my b value. So b equals 1.0184. My percent growth, remember we did this on the front. To find the percent growth, I'm going to subtract 1 from what I got here. So 1.0184 minus 1. When I do that, I get 0.0184, and I need to change that to a percent because that's what my problem's asking for. So if you forget, remember you can multiply decimals by 100. So if I wasn't sure what this was, I could just do times 100, and in this calculator, if it gives you a fraction, this button SD will switch it. So changing it to a decimal or to a percent, I get 1.84. So that's going to be 1.84%. Part C wants me to write an equation. Well, I've got my A and I've got my B that I found. So my equation is just y equals 37,000 times 1.0184 to the power of x. And lastly, they want me to find the population after 17 years. So I'm just plugging 17 into that equation. Excuse me. So we've got 37,000 times 1.0184 to the power of 17. We get y equals 50,440. We're talking about population. So that 5 is going to make that 4 go up to a 5. So 50,445 people. All right, so we're finished with this first paper. Remember, I gave you a few that you had to go through and do yourself. So 12, 10, and 9, along with, 4 and 5. So 4, 5, 9, 10, and 12 you are responsible for.